Hey guys, it's Miss Johnson and I'm here to bring you the second part of our notes for section 3.3. Today we're going to talk about a little bit more about how to choose an appropriate model. Yesterday we spent a lot of time talking about how to transform our data. We transformed the y's, then we transformed the x's and looked at the two together. And today we're just going to talk about how do we pick. We have all these models. We have the model of the original data, then we have the models of the logs transformed, then we have the model of the x's transformed. How do we choose which one is best? So we're just going to discuss that a little bit more. Our same premise is our focus here today. This is the same thing you saw yesterday about learning to transform those relationships and how it's a little bit different than just a multiplier and a constant. When we're taking a power model or a logarithmic model, it actually changes the shape of our data. Doing a multiplier and a constant only changes the spread of the data, but the shape of the data stays the same. So when we have nonlinear data, we want to apply a function. We use a logarithmic function, or we use a power function, or something like that. It's not just about units of measure. It's about changing the actual shape of the data. All right, so when we want to choose an appropriate model between the models that we have created, it says when choosing between different models to describe a relationship between two quantitative variables, one thing is to choose a model whose residual plot has the most random scatter. We want to see random scatter in that residual plot. That's an important thing. The other thing that we want to check for, it says if there's more than one model with a randomly scattered residual plot, choose the model with the largest coefficient of determination, or the R-squared. We looked at R yesterday, and we want it to be closest to 1 or -1, or you could just say R-squared closest to 1. Okay. This is what they suggest just because it's sometimes harder to tell when you're looking at that. But if you look at your R-squared value, those are all between 0 and 1. So which one is the best R-squared? Which one is the closest to 1? That's going to be our strongest linear model. So let's just do another example of looking at a couple of different models. If you didn't have your calculator out already, go ahead and grab it. You're going to want that today. So I'm going to go into my stat editor. I have values in the first 4 lists because we transformed our data just yesterday for L1 and L2, and we did the logarithm of x and logarithm of y. So I'm going to clear all my lists out, and I'm going to go back to L1 and put in those x values. So 1, 2, 3, 3.4, 4.2, 5.1, right? There's my x. Then go over to L2 and put in your y. 1.1, 8.4, 26, 40, 65, and 122. You can very clearly, even without looking at the scatter plot, you can tell this is not going to be a linear model. Look at how drastically your y values change as you increase your x values. Your x values don't change that much. They go 1 up to 5. Your y values go 1 to 122, and you have like an increase of 7, then an increase of 18, then your increases go crazy here. So you can very clearly see that this is not going to be linear. But let's go ahead and graph the scatter plot and do the LSRL anyway. I'm going to go do my LSRL. So I go to stat, I go over to calculate, I go to option 4. I want to change those out. They probably say L4 and L3 from what we did yesterday. Mine, I need to go back to L1 and then L2. I'm going to also go ahead and put that LSRL in my Y1. So if you go next to the store regression equation, hit the vars button, go over to yvars and enter on function, and I'm going to enter it into Y1. Then I hit calculate, and there's my linreg. So I can see that my LSRL looks like y equals -44.4 plus 28.3 times x. You can see that your R there is positive 0.94 roughly, or 0.936, okay? That's actually not a horrible correlation. That's a pretty good correlation, but let's go to the stat plot. Go into your stat plot, and let's just take a look at a scatter plot of this bad boy. So if I change that to L1, and I change that to L2, I need my X list to be L1, my Y list to be L2, and then I'm gonna go to my home screen, and I'm gonna hit zoom 9. It's not horrible, but it's not awesome. So I'm just going to say this is my X, this is my Y. We don't know what this data is. We don't have any labels for this data, so we're just putting X and Y. If I trace, use the trace button. Trace button is up above your up arrow next to the graph button. I'm going from 1 up to 5, I know that, or 0, I guess I could say 0 up to 5. And my Y variables are going from 0 up to 122. So this halfway mark is like 61, I guess, if you want to get really technical. And that's enough. This halfway mark would be about 2.5. That's enough to help us get our points in the right spot. So my first point is 1 and 1.1. Barely off the y-axis, or the x-axis. Then the next point is 2 and 8.4. Up a little bit more, but not a lot. Then I'm going 3 and 26. Almost halfway to that 61, but not quite. Then I go to 3.4 and 40, a little bit over halfway to the 61. Then I go 4.2 and 65. And then my big guy, the big jump, I go 5.1 to 122. So I would say this still looks pretty much like a curved model. Okay, my LSRL is also on my screen. If you got your LSRL on your screen, hopefully you see that. My LSRL goes like this. It's underneath that first point, and then it's over those points, and it's way underneath the last one. This is the LSRL, okay? The yellow is just me showing that there's a curve, but the green line is what my actual LSRL looked like. All right, not super awesome, definitely not linear. Let's do the residual plot. So I'm gonna go back into my stat plot. Now that I've calculated the LSRL, I can just go down to that Y list. So I'm in stat plot. I'm gonna keep my X list as L1, and then I'm gonna go turn my Y list into residuals. So you get your residuals from second list. Resid is the last option usually. For me, it's option 7. It just depends on how many things you have in how many lists you have in your calculator. So then I'm gonna quit out of that, and I'm gonna do zoom 9, and there is my, I still have my LSRL going through, but that's okay. So this is X, this is the resid of Y. So if I use the trace key, big residuals here. I have really big residuals. This is still going from 0 up to 5 because I'm still looking at the same X values. So that would still be my 2.5 roughly. But my residuals go from like -14 up to +22. That's a really big residual. That's a problem. Like your residuals should not be that big. So -14. So that right away tells me, like, if my residual plot's spanning almost 40 units, like that's telling me that this is not a great model already. But if I go ahead and put my points on there just for kicks, I've got 1 and 17. Oops, that's not what I wanted. There we go. 2 and -4 almost. 3 and -14. Is that really low one? 3.4 and -11.7, almost -12. Then 4.2 and -10, almost -9.4. So that's also way down here. And then the big guy, 5 and way up at 22. Yeah, that's a problem. Definitely not random scatter. Definitely looks like it has a little bit of a quadratic pattern to it of some kind, but definitely not random scatter. And those are really big residuals. Like, your residuals should not be that big if you have an appropriate model. So now let's change it to log. So go back into your stat editor. I'm going to be done messing around with that residual plot. I'm going to go into L3. If you remember doing this yesterday, go into L3, hit enter so that your cursor is blinking on L3, and we're going to do the log of Y. So I want log, and I'm going to do L2, which is above the 2, so second 2. Gets you the L2, I hit enter, and my values go down. Now I want to calculate that LSRL, so go to stat, calculate. Instead of L1 and L2, I'm going to do L1 and L3. And I'm going to restore that equation. So I like this. I like to do this because I like seeing it on the graph with the stat plot. So if I store my LSRL, I want to go into vars, over to yvars, enter on function. I'm going to do L1 or Y1 again. Just puts it in the first slot, and that's fine. I don't need the old LSRL because I'm done with it. Oh, I suppose I probably should have written the old LSRL down. Did I do that? Anyway, I don't even know if I wrote the old LSRL down. I think I did, but I'm not totally sure. But that's okay. So here's our LSRL for this one. Remember, now I'm looking at the log of y, not just y. So the log of y is equal to, my y-intercept here is negative 0.19, if you will, and then plus 0.48 times my x. And I haven't changed x, I've only changed y. My correlation is great here. My correlation is 0.969 or 0.97, if you will. That's a pretty good correlation. And even if you look at that r squared, we didn't talk too much about r squared yesterday, but if I look at that r squared, I want it to be closest to 1, as close to 1 as possible. So 0.938 is what I'm at there. That's a pretty good r squared. It's not awesome, but it's pretty good. It's pretty strong. So now let's look at our stat plot. So stat plot, I want to change that to L1 and L3, get rid of the residuals, L3. I like going to the home screen before I do Zoom 9. I don't know, sometimes it just makes me feel like I'm not going to enter something in on my stat plot editor that I was doing. All right, so this looks pretty good. I still see a little bit of a curve, and what's funny is the curve almost turned concave down when I took the logarithm, which is pretty interesting to me. So I know I'm still going from 1 to 5. Probably went up a little bit too high. So that's my 5. This is still just my x's. So this is about 2.5. But now my y values are going from 0 up to 2.08 roughly. So I'll say that that's my 2. Here's my 1. So then let's look at the points. My points look like this. I have 1 and 0.04, so barely above the x-axis. Then I have 2 and 0.9, which is just under that value of 1. Then I have 3 and 1.4. Then 3.4 and 1.6. Then move her down a little bit, and when I get to 5, this is where it kind of almost takes a turn and looks like it's curving down a little bit. Do you see kind of what I'm looking at? If I tried to like kind of connect those points, it almost looks like it's curving down. It's almost like we had an opposite effect of those points. My LSRL though, it looks pretty decent. It goes through, it's not perfect, but it goes through kind of like that. Okay, that's what the LSRL would look like from there. All right, let's do the residuals of this bad boy. So go back into your y equals, go into your stat plot, sorry, not y equals, into your stat plot, leave your L1 the same, but now go down to where you had L3 and change that to residuals. So I go to second list, and residuals is my option 7. It might be different for you, but that's what mine is. And then I'm going to do quit. No, I hit the wrong button. I hit trace. I meant to hit zoom. So I'm going to go home, zoom 9. Okay. Yeah, I see a pattern. Do you guys see the pattern? If I trace here, I'm still looking at just x, and I'm looking at the resid of log of y. That was supposed to be a g. So this is still just 0 to 5, being 2.5 in the middle, 2.5 in the middle. My residuals go from negative 0.25 up to 0.15. So they're definitely a lot smaller. That's really good. Negative 0.25 was this one down here. But if I graph these, you know, you've got your pattern kind of like this. And then one down here, and then one down below. So I just threw those on there rather quickly, just for you to see kind of the pattern. It doesn't look like random scatter to me. You want random scatter, and this very looks like a quadratic that's facing down. So there we go. We got to go back to the drawing board and write a new one with the log of x. All right, so here's our log of x. Let's take care of that. Put log of x into L4. Go back to your stat editor. Stat edit. L4. Go up and enter so your cursor's down at the bottom. And then I'm going to do the log of L1, which is my x variable. And this is the one where now you're a little bit backwards because your x list is L4 and your y list is L3 because we did log of x, or we did log of y first. So go into your stat plot, go to L1, or go to the x list and change it to L4. Go to the y list, clear out your residuals, change your y list to L3, and then I'm going to quit that, and I'm going to do zoom 9. Hey, that looks pretty good. I didn't do my LSRL. Let's do that. Go stat, calculate, option 4. I want L4 and L3, and I'm going to store that regression equation again. You go to vars, then over to function, or y vars, then function, then y1. Calculate. Check out that correlation. Here's what I get for my LSRL. I have y, nope, Johnson. The log of y, log of y equals, I should have done this on on the line below. My b value is 0.049, we'll call it, plus 2.874 times the log of x. There's my LSRL. Check out your correlation. It's pretty sweet. 0.9997. It does not get much better than that. And your r squared is 0.9994. And again, does not get much better than that. Does not get much closer to 1. So this is pretty sweet. This is pretty cool. My graph, if I look at the graph, gosh, my LSRL goes right through the middle of all those points. If I trace the points, I'm going from, on x, 0 up to 0.7. So 0, this is now log of x, up to 0.7. And my y's do that 0 to 2.08, 0 to 2. So there's my 1. This is 0.35. I just like to give myself a halfway marker so I can kind of see what's happening there. And if I trace, I got a point almost at the 0, 0. Then I got a point at 0.3 and 0.92. Then I got a point at 0.48. And I mean, they're just like all right in a line. If I just kind of graph them, they look like that. My LSRL goes literally almost directly right through them. Woo! If I do the residuals, let's take a look at what those residuals would look like. Go into your stat plot, leave your L4 in there, clear out the L3 for the Y list, and do the residuals, which is second list, resid is the bottom option. I'm gonna hit enter. I like to go to my home screen, then I do zoom 9 and check out your random scatter. I have a point. I'm not doing a good job labeling these because I'm kind of running you through fast, but I got one here, I got one there, I got one there, there, and there. There is very much no clear, obvious pattern in this residual plot, which is exactly what you want. So this was the log of x. This was the resids of the log of y. So again, random scatter, we like it. That's our best random scatter residual plot, which is good. Your R was great. Your R squared was great. This LSRL, the LSRL of the log of y equaling all that stuff, and then the log of x is definitely your best model. So that's what you're looking for. I went through that example a lot more quickly than I did the example yesterday, so hopefully you were able to kind of follow along. Don't be afraid to pause, to back it up. There's also tech corners in your textbook. There's those kind of light reddish sections that say Tech Corner. That Tech Corner is going to take you through how to make a residual plot and how to put all that stuff into your TI-84. So you can follow along and read through the directions in that Tech Corner as well. And if you ever want to do a graphing calculator piece together, we can work on that. But yeah, thanks for listening, and I will catch you next time.